An opening statement from Professor Behe.
Several key scientific discoveries point strongly to the conclusion that the universe and life are the products of intelligent activity. Those discoveries are, first, that the universe had a beginning. Second, that the universe is finely tuned for the existence of life. Third is the intractability of the question of the origin of life. And fourth is the discovery of massive interactive complexity in the cell. Let me explain this fourth point. The cell is run by molecular machines. For example, in the first figure, it shows the bacterial flagellum, which is literally an outboard motor that bacteria use to swim, with a rotor, stator, bushings, drive shaft, and more. The interactive complexity of the parts of the flagellum appears to indicate that the machine was purposely designed. Science should not shy away from that idea. The second figure shows the familiar drawing of very similar embryos of fish, salamander, chicken, and human gradually turning into different forms. Recent work, however, has shown that the drawing is fraudulent, faked by a man named Ernst Haeckel in the 19th century. Thus, a big problem that Darwinism was thought to have solved, embryology, turns out not to have been solved after all. Such strong challenges, both new and old, show the need to break out of Darwinian patterns of thought, beginning with the acknowledgement that much of life in the universe appears purposely designed.
Thank you, Professor Behe. Professor Miller.
Michael, I'd like to start out by pouncing upon the notion of irreducible complexity, which is a point that you make again and again in your book, Darwin's Black Box. On page 43 of this book, you use a mousetrap as an example of irreducible complexity. It's right here in the book, and you point out that a mousetrap has 5 parts, and like a biochemical system, you claim that if you take one of those parts away, it won't work anymore. The 5 parts include the base, the spring, the clapper, which does the business end, a catch, and a little piece to hold the bait. And I have a working mousetrap here. It's actually a rat trap, so I want to be very careful with my fingers. I have here another trap from which I have removed a part. I've taken away the trigger. According to Dr. Behe's analogy of the mousetrap as irreducibly complex, I have now removed a part, and therefore it must not work. And this applies to biochemical systems as well. Exercising as much care as I can, I am going to take the catch. Whoops, a little more care.
Is that relevant to the argument?
It is directly relevant, Mike. And I'm going to set it up, and what I have done is to remove one part and modify another. I hope the cameras can see this. I want to demonstrate to the audience that the working mousetrap works just fine. And I want to demonstrate to the audience that the one that Dr. Behe said was irreducibly complex, if we remove a part, he says it won't work anymore. It looks like it works fine.
Can one of you explain the significance of irreducible complexity?
I would be delighted to, since I'm asking the question.
Is there a question in
the
here
argument? The question is straightforward. The argument is that when you see a system made up of multiple parts, such as a biochemical system, if you take one of those parts away, it will not work, and therefore the separate parts could not have evolved. And what I've just shown you is that your analogy, which you use to mousetrap, first of all, is flawed, and secondly, it doesn't apply to biochemistry either, because biochemical systems can often function missing one of their parts. Isn't that true?
Well, it turns out it is not true. Since my book has come out, a number of people have emailed me and sent me letters about ways that perhaps a mousetrap could function without all of those parts. And it turns out that Professor Miller didn't do away with the catch. He used another part of the mousetrap as a catch. The mousetrap still needs those 5 parts. In the absence of something functioning as a catch, it just doesn't work. Other people have emailed me that perhaps you can do away with the platform. You can do away with the platform by nailing all of the parts of the mousetrap to the floor.
Right now,
just a second.
Rather than your speech about the mousetrap, and explain why this is biochemically relevant.
Listen, you asked a 2-minute question in my 5-minute talk.
I agree. You get some time.
Somebody emailed me that you do not need the platform either to make the mousetrap work. All you have to do is take the parts and nail them to the floor, and then it works just fine. Well, you know, you're using the floor as the platform. So you can use a rock as a catch or something. The point is you need all those functions. And in my book, which Ken alluded to, I explain why many biochemical systems are like that too. You need all those functions to make them work.
Now let's see if that's correct. Let's take a real biological example. And in the chart that I have here, what I've shown basically is a very complicated chemical pathway in which fucose, a sugar, is metabolized. It turns out that if you carry out an experiment in which you delete the gene, which produces the enzyme that metabolizes fucose under controlled conditions where you can observe them, what happens in a few generations is that the bacteria evolve a new enzyme. They evolve an enzyme that works in the reverse direction. They do it by modification of pre-existing genes, and they evolve a new biochemical pathway. This, Michael, I would suggest, is the exact thing which you are claiming is impossible, and yet it can be routinely observed under laboratory conditions. Again,
well,
isn't that true?
I disagree with you. No, that is not irreducibly complex. Additionally,
can you explain why it's not irreducibly complex? It's got all the parts.
Take a crack at explaining what irreducible complexity
Let me do something else. Instead of having a biochemistry lecture here, my book, in which I explain these concepts, which cannot be explained very well in a few minutes, has been reviewed by a number of scientists. What have they said? In National Review, it was reviewed by a
Excuse me, I would suggest that a discussion of Dr. Behe's reviews is not relevant to the question.
Well, I'm allowing him a 30 or 40 seconds.
James Shapiro, a biochemist, a professor of biochemistry at the University of Chicago, wrote in National Review, "There are no detailed Darwinian accounts for the evolution of any fundamental biochemical or cellular system, only a variety of wishful speculations." So apparently he does not think that this is a relevant example either. Jerry Coyne, an evolutionary biologist at the University of Chicago, wrote in Nature, the world's leading science magazine, science journal, "There is no doubt that the pathways described by Behe are dauntingly complex and their evolution will be hard to unravel. We may forever be unable to envisage the first proto-pathways." Nobody has claimed that these things have been explained.
No, guess what? We're out of time. Thanks very much, Mr. Behe.